All right. So, when we talked about arrays in C++, we said it's basically a variable that can hold many things. So, I'm just going to call that nums and maybe say 500. I want to hold 500. But one of the issues with this array was we couldn't add to it later on in our code. And that's going to hurt us, especially in graphics when we want to add and take away things as we go. And the other thing is you kind of have to know the size of the list you're going to hold before you start your coding. And that's not necessarily going to be very useful for anything, right? Let's say I'm making something that like keeps track of all the students at Saunders. Well, every day students are leaving and coming in, and that needs to be a more dynamic list. So here's how you do it. You have to include a special library. It's got kind of an awkward name considering vector is already used in SFML, but it's called vector. Okay? And the way you make a list of integers now is you write the word vector like that. And then in pointy brackets, you write the type, and then you write the name. So I would do nums like that, okay? And after that, most of the stuff is the same, how you access items in this list. If you want to make 500, you don't use a square bracket. You actually make a circular bracket. But that will now make a list of 500 things. Let me just debug that. And we should see, I think it automatically populates them with zeros as well. Let's have a look in the watches window and see if that will work. Okay, I'm going to hit watches, and I will see that I have a vector of length 500. It says capacity of 500. Don't worry about capacity right now. That's just the way for the computer to manage the memory, because this thing is dynamic now. It can change on the fly, unlike the traditional array can. So let's see what's inside of this thing. It looks like it's automatically populated with zeros. That's another thing the array wouldn't do, right? It would just take whatever was in memory and fill it up. But now, it's all full of zeros. Okay? So there's not much to it. Like there's a few more extra options. But if I go, let's say the other day I filled my array from the numbers 1 through 500. It's the same idea here. Okay? Int I equals 0. I less than 500, I plus plus. I can still go and access it just like I would a regular array. I just go nums I, so I'm going to go through all 500 of them and let them equal I. Now when I run that and hit debug, we will see that it's filled with the numbers 0 through 499. Not much has really changed about how that list works. Okay, still just using square brackets. The only thing that changes is the initialization of it. But there it is. There is the list of the numbers 0 through 500, just like it was with an array. So what's the big deal about it? Well, one of the first things that's nice about a vector is it knows how big it is. So if I go nums and hit dot, nums is the name of my list, you can see there's all sorts of functions associated with it. Much like a string has a size associated with it, nums also has a size. So we can use that to avoid a lot of errors where our vector is changing and we're counting through it. If I hard-coded 500 and then took one off of here, my program would probably crash. So I'm going to do nums.size, like that, okay? And that will fill up a list of the same thing, 500, okay? What if I want to take one away? Watch this. Nums.popback. Okay? That is a command that will take the last thing in that list and erase it. Erases last in the list. Okay? So watch what happens when I output the size of my vector. It shouldn't be 500 anymore. It should be 499 because I took away the last one. There you go. Okay? If I get rid of the pop back there, it should be 500. Cool. Suppose I want to take the last one off, which was 499, right? And then I want to add the number 5 million to the end of the list. So there's a command called push back. And then all you have to do is put what you want to add to your list in brackets. My list is holding integers, so I'm going to write the number 5 million. Oops. Okay. Now, if I output the last element in there, it should say it's 5 million. So now I can add things to my vector, which is pretty sweet. Okay? Suppose I want to erase the 300th element. How do I do that? This one's kind of awkward, but you go erase like that. It'd be nice to just write 300 and say erase the 300th one. Doesn't quite work like that. You actually have to give it the memory address of the first element. Don't ask me why. I don't know why C++ is set up like that. But the memory address of the first element is nums.begin. And then you write plus 300 and it'll erase the 300th one. Let me erase the 100th one and then let's look at the list and see if the 100th one is gone. So I'm going to hit play. I'm going to go to watches. Let me see the 99th one. Did it erase it? I don't really see it gone. Do you guys? Why didn't it erase it? Let me try to erase the very first one. Let's see what happens. Oh, I know why, because I'm on this stop sign here. Sorry. Let me erase the 100th element and see if it gets erased. Okay, so this is going to be really important for graphics because we're going to have dynamic arrays full of drawings. Look, deleted the 100th one. There is nothing in there with the element 100 in it. However, 100 is now 101. 101 is 102. It kind of just moved everything over. Okay, that's the power of the vector. Okay, so what does a vector do? It is exactly like an array, except it's dynamic. It knows its own size. We could delete stuff from anywhere inside of it, and we can also quickly delete the last element, and we can also add stuff to the back of it anytime we want, okay? At the cost of a little bit of speed and memory issues. But that's not important for us when we're making simple little projects, so we don't worry about that, okay? There are other containers as well that work exactly the same but have different memory management schemes. There's one called a list. There's one called a queue. There's one called a DQ. DQ something different. There's one called linked list or something like that. No, I can't remember. There's a whole bunch of different containers. The one we always use is vector. It's kind of the most all-around speed versus performance, kind of performance versus usability. So have a look at that lab on containers.